Students, let us discuss today some important questions and the questions which are appeared in the previous entrance exams in 6th A group. 6th A group of elements are also known as chalcogens. 6th A group of elements and also known as what? Chalcogens. Under this we discuss some important questions and the questions appeared in the previous entrance exams. Question number 1. Which one has the highest bond energy? Among the chalcogen atoms, we take 6th A group of elements in between the atoms, which is having highest bond energy. Option A is given as what? O2O, sulfur to sulfur, selenium to selenium, tellurium to tellurium. When we talk about the oxygen to oxygen, suppose you are talking about a single bond. This particular is carrying electrons over each oxygen atom. Over each oxygen atom, 3 pairs of electrons are there after single bonding. After single bonding between oxygen and oxygen, 3 pairs of electrons are there. There is a repulsion between the electron pairs is there. Between the lone pair, there is a repulsive interaction. Therefore, this particular oxygen to oxygen bond energy is very less. It is nearly coming to be only 138 kilojoules per mole. In the case of sulfur to sulfur, the electron pairs, repulsion between the electron pairs is less. Because of smaller size, the repulsion between the oxygen to oxygen, lone pair of electrons repulsion is more. Therefore, bond energy is less. But sulfur to sulfur, due to little bit bigger atomic size, repulsion between the lone pair of electrons is less. Therefore, sulfur to sulfur, bond energy is high. It is nearly found to be 238 kilojoules per mole. And selenium to selenium, and still atomic size is increasing. Therefore, the selenium to selenium, due to bigger atomic size, bond energy is less. And still, in the case of tellurium to tellurium, the atomic size is very big for tellurium atoms. Therefore, oxygen should possess actually, oxygen to oxygen bond energy should be more. But because of repulsion between the lone pair of electrons, the bond energy of oxygen to oxygen is less. Coming to be sulfur to sulfur, it is more. In comparison to this one, oxygen, sulfur to sulfur bond energy is more. Therefore, for the question number 1, answer is B. Question number 2. Which oxide is more acidic? Coming to option A, Al2O3. Option B, Na2O, MgO and CaO is given. Well known to you this particular sodium, magnesium, Na2O. Sodium, magnesium, calcium belong to what? This is alkaline metal. The remaining what? Alkaline earth metals. Yes, their oxides are what? Strongly basic. Therefore, sodium monoxide we take and magnesium oxide, calcium oxide, they are strongly basic. Coming to aluminium, well known to you, Al2O3 is amphoteric. Among these, you are asking which is more acidic. So, definitely sodium, magnesium, calcium belong to alkali and alkaline earth metal. Their oxides are strongly basic. Remaining aluminium, 3rd A group of element. Moreover, Al2O3 is amphoteric. Definitely in comparison to the 3, Al2O3 is more acidic. Therefore, for the question number 2, answer is A. Question number 3. Oxygen gas can be prepared from solid KMnO4 by dissolving the solid in dilute HCl, dissolving the solid in dilute sulfuric acid, treating the solid with the H2 gas, strongly heating the solid. Generally, KMnO4 on treating with HCl you take, that is converting into what? MnCl2 and KCl, etc. Then dissolving the solid in sulfuric acid also, you are getting KMnO4 is sulfuric acid, generally you are getting K2SO4, MnSO4. There is no formation of any oxygen. Coming to treating the solid with H2. H2 is a reducing agent, it is reducing that one. There is no choice of getting any oxygen. Strongly heating the solid. Consider strongly heating the solid, 2 KMnO4. Strongly heating near about 250 degrees centigrade consider. Then you are getting here K2MnO4. Potassium permanganate converts into potassium manganate plus you are getting MnO2 and oxygen. See, KMnO4 on strong heating only converting into what? Potassium manganate MnO2 and O2. So this on strong heating only you are getting oxygen by dissolving in HCl or treating with sulfuric acid, you are not producing any oxygen. Therefore, question number 3, answer is D. Question number 4, which does not give oxygen on heating. Take option A is given as HGO, second one KMnO4, third one KClO3, ammonium dichromate is given. So this particular HGO on heating, yes, you are getting 2Hg, oxygen deliberating. One of the method of preparation of oxygen is this one. Coming to KMnO4, just now you have seen this on heating to 250 degrees centigrade. Yes, you are getting what? K2, MnO4, MnO2 and oxygen. See, oxygen you are getting on heating of KMnO4 also. KClO3 well known to you. This on heating in presence of MnO2 catalyst around 250 degrees centigrade. You are getting KCl and followed by 3O2. So all these on heating you are getting oxygen. But on heating of this particular ammonium dichromate, heat it, you are getting nitrogen gas followed by Cr2O3 followed by 4H2O. There is no formation of oxygen. Here you are getting what? Nitrogen gas. So for the question number 4, answer is D. Coming to question number 5, mixture of O2 and N2O is used as A. fuel, B. anesthetic, C. in welding, D. oxidizing agent. We talk about this particular oxygen and N2O. Is generally used as anesthetic. Generally, actually, N2O is actually poisonous gas. On inhaling moderate quantities, it is actually generating hysterical laughter. Therefore, this particular N2O is commonly known as what? Laughing gas. Whenever it is mixed with oxygen, a little amount, small required amount, then we can get anesthesia. That means what? N2O is acting as what? Anesthetic gas. Therefore, mixed with oxygen and N2O mixture, generally used as what? Anesthetic gas. So, 5th question, answer is B. Question number 6. Oxygen can be obtained from bleaching powder by adding dilute acid, passing carbon dioxide, heating with cobalt salt, adding alkalis. In this case, you see the decomposition of bleaching powder catalyzed by cobaltous chloride, CoCl2, then you are getting CaCl2 plus oxygen. In this way, you can get oxygen from bleaching powder. Therefore, the question number 6, adding dilute acid is given. Generally, adding dilute acid, you are getting what? Chlorine gas. Passing carbon dioxide, also you get chlorine gas. And heating with cobalt salt, you see in this way, this is decomposing and producing oxygen. Therefore, for the question number 6, answer is C. Question number 7. Liquid of oxygen, first one, an important constituent of rocket fuels. Generally, oxygen is the oxidizing agent, generally used as rocket fuels. And it is used for artificial respiration with CO2. See, mixture of CO2 and O2. O2 90%, CO2 10%. This particular mixture is used as carbogen. Under the name carbogen, this particular O2 and CO2 mixture is used as artificial respiration. Coming to say mixture with the finely divided carbon is explosive. Finely divided carbon is active carbon. What we call active charcoal, active carbon. Whenever active carbon is mixed with oxygen, then easily it bonds. There is a explosion may take place. Therefore, all of these. So, liquid of oxygen can be used as what? The fuel in the rocket fuel, and also artificial respiration, and also explosion with intermixing with what? charcoal or carbon. So for the question number 7, all are the correct answers. Question number 7, answer is D. Question number 8. The pale blue colored gas which condenses to deep blue liquid and blue violet solid is. Option A is what? F2. Option B O3. Option C NO. Option D Cl2. So this particular O3 is actually, it is what? Pale blue in color, pale blue. This you are condensing to liquid, consider O3 liquid, right? This is what? Deep blue. Deep blue. This particular you are solidifying, consider O3 solid. O3 solid will be violet crystals. Violet, blue violet or violet blue. Blue violet crystals. Blue violet crystals. So O3 actually in the gas state, light blue, pale blue. Whenever it turns to liquid, it is getting little darkness, deep blue it is becoming. If you solidify, you are getting what? Blue violet crystals. So for question number 8, pale blue colored gas condensed to deep blue and again blue violet crystals. Only the answer here is ozone. So the 8th question answer is B. Question number 9. Which is an ozonide? Ozonide means it should be O3 minus. This is ozonide. O3 minus. Option A is what? KO3. Option B is what? Ammonium ozonide. Ammonium ozonide. C is given as more or less identical it is looking. Cr2O3. D is both A and B. This is what? Potassium ozonide. O3 minus we want. No. Yes. In KO3 O3 minus. Ammonium ozonide O3 minus. But Cr2O3 it is actually chromic oxide, you can say. Chromium dichromium trioxide or chromium sesquioxide we can call. But Cr2O3 there is no ozonide. Only oxygen is there. Therefore, the question number 9, A and B are the answers. So according to our options, 9th question now answer is D. Question number 10. Reagent used to distinguish H2O2 and O3. Option A is given as what? PBS, starch and iodide. Starch and iodide. Starch and iodine. Starch and iodine. Next option 3 is KMNO4. Option D is bleaching powder. See this particular with PBS, either you take ozone or you take hydrogen peroxide. Both similarly react. PBS they can oxidize to PbSO4. Both can oxidize lead sulfate to lead sulfate. Starch and iodine you take, either you take O3 or you take hydrogen peroxide. Both are liberating iodine. Therefore, iodine with the starch becomes blue. So both are giving the same iodine only. Coming to KMNO4. KMNO4, this particular hydrogen peroxide only decolorizes KMNO4 by reducing KMNO4 to MnSO4 as sulfuric. This particular hydrogen peroxide acts as oxidizing agent and reducing agent. But ozone can only act as what? Oxidizing agent. Therefore, here KMNO4 reduced by hydrogen peroxide to colorless MnSO4. So, in presence of hydrogen peroxide only, potassium permanganate can be decolorized, but not with the ozone. Coming to CaOCl2, either you take ozone or you take hydrogen peroxide, both are liberating oxygen again. So, both are behaving same type with particular CaOCl2. So, only option this particular KMNO4, option C, hydrogen peroxide only decolorizes but not ozone. So, the reagent used to distinguish H2O2 and ozone is? For 10th question, answer is C. Question number 11. Which metal sticks to glass plate, loses its meniscus after treatment with ozone? A is given as what? Silver. B is given as what? Mercury. C is given as copper. D is given as what? Lead. Look here, mercury with ozone, whenever mercury comes in contact with ozone, it is actually producing mercurous oxide. Look here, O3, then you are getting mercurous oxide, O2. Whenever mercurous oxide is produced, then this particular mercury losing its meniscus, that means what? Losing its surface tension. Losing its meniscus, that it is losing its surface tension and sticks to the walls of the container like this. Walls of the container like this. Therefore, for question number 11, answer is B. Question number 12. Ozonization of water is carried out to remove. See, one chlorine gas or bleaching powder, you take again ozone. These are all easily decomposing, liberating nascent oxygen. Nascent oxygen. O3 easily decompose, produce O2 and nascent oxygen we are getting. Nascent oxygen. So bacterial impurities, bad taste, excess of chlorine present, calcium and magnesium salt present in it. Generally, ozonization of water, ozone on decomposition producing what? Nascent oxygen. Nascent oxygen is highly reactive. This actually kills bacteria, any microorganisms are there in the water. Therefore, the sterilization of water, for the purification of water, generally we use ozone. Therefore, for the question number 12, answer is A. Question number 13. Bond angle in ozone molecule is 108.29. Actually, ozone molecule, it is angular. This is the structure of ozone molecule. The bond angle in this coming to be generally 116 degree. It is 116 degree 80 minutes. In some book they write it 116 degree 49 minutes. Okay, it is around 116 degree. Therefore, question number 13, answer is C. Question number 14. Compound of sulfur is used in electrical transformers. What is SO2, H2S, SO3, SF6. See, among all these particular sulfur compounds, all are actually more or less reactive, but SF6 is what? Saturated. Smaller sulfur atom is occupied by 6 fluorions, thickly occupied by fluorions. Therefore, SF6 is what? Stable and inert. Because of this particular reason, SF6 generally used in electrical equipments, electrical transformers. So, for the question number 14, only the answer is D, which is more inert. Question number 15. SO2 reduces magnesium, H2S, K-4 and all of this. In this particular, SO2 is not reducing magnesium metal. Magnesium itself is actually a reducing agent. This SO2, there is no choice of reducing magnesium metal. Coming to H2S, H2S is also a reducing agent. So SO2 cannot easily reduce this particular H2S. Coming to K-4, presence of water, 5 SO2 take, then you are getting K2SO4, 2 MnSO4, and 2H2O, 2H2SO4, 2H2SO4. These are the products. See, K-4 is reduced to K2SO4 to MnSO4. So, K-4 reduced to MnSO4, Mn plus 7 is reduced to Mn plus 2. Therefore, SO2 can reduce KMnO4. So in this case answer is C. Question number 15, answer is C. Right, question number 16. A colorless gas on passing through bromine water decolorize it. The gas is the gas which is decolorizing bromine water. Among the options given is HCl, HBr, HCl, HBr, CO2, SO2. Now you take bromine plus bromine water, take SO2, then you are getting here 2H2SO4 and 2HBr you are getting. This particular HBr is converting into simply this particular bromine with water and sulfur dioxide. This is what bromine water with sulfur dioxide converting into HBr. Whenever bromine converting into HBr, that will be decolorized. This particular conversion of bromine water to HBr only possible by SO2. Therefore, the question number 16 answer is D. Question number 17. SO3 on reacting with constant HCl gives A. Chlorosulfonic acid, B. Cl2 plus H2SO3, C. Cl2 plus H2SO4. None of this. Let us see now SO3 and HCl reaction. SO3 plus HCl reaction. Then you are getting here chlorosulfonic acid. This you are getting chlorosulfonic acid. Therefore, for question number 17, answer is A. Question number 18. The contact process of sulfuric acid, SO3 dissolves in sulfuric acid to give. There are actually some steps are there. Sulfur dioxide converted into sulfur trioxide. In the contact process, sulfur dioxide converted into what? Sulfur trioxide. Sulfur trioxide dissolved in sulfuric acid. Then you are getting here H2S2O7, H2S2O7. This is the actual reaction. What are the options given is permonosulfuric acid, B. Thiosulfuric acid, C. Pyrosulfuric acid, D. Paradisulfuric acid. Pyrosulfuric acid, nothing but this is pyrosulfuric acid. We can call it as what? Oleum. Oleum or pyrosulfuric acid. Pyrosulfuric acid. Therefore, SO3 with sulfuric acid, pyrosulfuric acid produce oleum. This particular oleum again H2S2O7 diluted with water, then you will be getting sulfuric acid. Question is that SO3 with sulfuric acid, what is the product you are getting? Oleum or pyrosulfuric acid. Therefore, question number 18, answer is C. Question number 19. Poison for platinum, a catalyst in contact process of H2SO4 is. So, in the contact process, they will use vanadium pentoxide and also platinum. Here, sulfur and phosphorus, next followed by arsenic. What is the next option? Carbon. This particular arsenic actually poisons the catalyst. In contact process, the main impurity, the arsenic impurity. The arsenic impurity reacts with the catalyst. It decreases its efficiency, what we call it, the poisons the catalyst. Therefore, this arsenic should be removed by using ferric hydroxide. By using ferric hydroxide, we remove this particular arsenic in the contact process. Therefore, the question number 19, the poison for platinum is nothing but arsenic. So, question number 19, answer is C. Question number 20, H2S4 reacts with sugar and acts as. First one, dehydrating agent, an oxidizing agent, A sulfonating agent? None of this. See, remember sulfuric acid is basically strong dehydrating agent. Dehydrating agent. It dehydrates sugar to carbon. See, what is sugar? C12, H22, whatever. Sugar or sucrose you take. This with concentrated sulfuric acid. Dehydration takes place, then minus 11 H2O, then you are getting what? 12 carbon. What is this particular reaction? Dehydration of sugar. So for the question number 20, answer is A dehydrating agent. So answer is A. Question number 21. Concentrated sulfuric acid displaces HCl from chlorides because A. Concentrated H2SO4 is stronger than HCl. B. HCl is a gas where H2SO4 is a liquid. C. Sulfates are more soluble in water than chlorides. D. Sulfates are less soluble in water than chlorides. Actually, sulfuric acid displacing HCl from chlorides. HCl from chlorides. So we take a sulfuric acid, H2SO4, take a KCl suppose. Then you are getting what? K2SO4 plus 2HCl. Sulfuric acid displacing chlorides. Displaces HCl. Displaces HCl from chlorides. Therefore, it is stronger acid than HCl. Therefore, this particular sulfuric acid displacing chloride in the form of HCl. Therefore, question number 21, answer is A. Question number 22, when water is added in concentrated sulfuric acid, the reaction is exothermic. See, whenever you are adding water to sulfuric acid, take a container, take in this sulfuric acid, to this you are adding water to this. The temperature of this particular is actually increased because of formation of hydrates. Sulfuric acid is forming hydrates like this, monohydrate, dihydrate. Due to formation of these particular hydrates, the temperature may rise up to even more than 120 degrees centigrade because the hydration of this particular sulfuric acid is exothermic in nature. Option A is given as H2SO4 is viscous. B. Hydrates of sulfuric acid are formed. C. Sulfuric acid is corrosive and D is what? None. So because of formation of hydrates and the temperature rising to even more than 120. So for the question number 22, answer is B. Question number 23. Sulfur on oxidation with hot sulfuric acid gives SO3, SO2, H2SO4. D is what? None. Sulfur on oxidation with hot sulfuric acid. See, sulfur plus H2SO4. Then you are getting here sulfur dioxide you are getting followed by 2H2O. 3 sulfur dioxide you are getting here. So sulfur with sulfuric acid you are getting what? Sulfur dioxide. Therefore the question number 23, answer is B. Question number 24. Which is more suitable for storing concentrated sulfuric acid? Option A is what? Copper vessels. Option B is what? Aluminum vessels. Option C is what? Earthen vessel. Option D is glass vessels. See, concentrated sulfuric acid reacts with the almost all the metals more or less. So reacts with copper, reacts with the aluminum. Earthenware. Earthenware also it will react. In the earthenware, what is actually? There is actually sand in there. There is any other minerals may be there. So slowly it actually, concentrated sulfuric acid corrosive in nature. Therefore, it also reacts with the sand and whatever the minerals present in the sand. Therefore, the 3 vessels are not suitable to store sulfuric acid. Sulfuric acid is better to store generally in a glass vessels. So for the question number 24, answer is D. Question number 25. When sulfuric acid added to charcoal, there is no reaction. Water is formed. SO2 and CO2 are evolved. CO and SO2 are evolved. What is actually sulfuric acid and charcoal. Take carbon plus sulfuric acid reaction. Then we are getting here CO2, SO2 and 2H2O you get. Take this CO2 and 2SO2. Therefore, CO2 and SO2 are the products. Therefore, question number 25, SO2 and CO2 are evolved. So, question number 25, answer is C. Question number 26, which of the following acts as pickling agent? Let us see what is actually pickling process. A is HCl, B is HNO2, C is H2SO4, D is at HNO3. What is actually pickling process? Pickling process. This pickling process generally used in metallurgy. Suppose ores are carrying some basic oxide layers. This particular actually treated with what? Concentrated sulfuric acid. Sulfuric acid removes the basic oxide layers in the ore. This particular process, the process in which removal of basic oxide layers from the ores, known as what? Pickling process. Generally sulfuric acid is applied, therefore sulfuric acid is known as what? Pickling agent. Therefore, the question number 26, answer is C. Question number 27, which gives off oxygen on moderate heating, on little heating, which is actually liberating oxygen. First one is what? Cupric oxide. Second one is what? Mercuric oxide, zinc oxide, aluminum oxide. These are options. Among all, this is more stable. This is also and Al2O3. But you see, you want to produce oxygen, this HGO on heating, it is less stable among these, easily liberate oxygen. So, for the question number 27, answer is B. Question number 28, which of the following statement regarding sulfur is incorrect? Let us see incorrect statement regarding sulfur. Option A, S2 molecule is paramagnetic. We agree. S2 molecule is more or less identical to O2 molecule bonding. Therefore, S2 molecule is also paramagnetic. Coming to B, sulfur at 115 degrees centigrade consists of mostly S-side rings. Yes, sulfur actually carrying S-side rings up to 115, 118 degrees centigrade. Sulfur melts, but S-side rings remain as such only. Next, this particular option number C, 600 degrees centigrade, the gas mainly consists of S2 molecule. 600 degrees centigrade, sulfur completely vaporizes. That particular vapor mainly carrying S2 molecules. The dominant species in the vapor is, sulfur vapor is S2 molecules. Coming to D, the oxidation state of sulfur is never less than +4 is said. In many compounds we see sulfur is -2, sulfur is +2. No, therefore that is not correct. Never be less than +4, that is not the correct answer, correct option. So, question number 28, answer is D. Question number 29, oxalic acid when heated with concentrated sulfuric acid, H2 and CO2 are produced, CO and CO2 are produced, H2O2 and CO are produced, CO2 and H2S are produced. Now, see oxalic acid. COOH taken twice, oxalic acid, concentrated sulfuric acid, it is a dehydrating agent, dehydrates. You are getting mixture of CO and CO2, CO and CO2 you are getting. So, therefore, question number 29, that CO and CO2 are the answers. Question number 29, answer is B. Question number 30, a gas that relights glowing splinter is. Option A is what? H2, B is what? O2, C is N2, D is NO2. The gas which supports combustion is oxygen. Therefore, a splinter is there. It is what? Reddish, red splinter. Whenever you put into oxygen, it is actually glows. It catches fire. Therefore, coming to question number 30, answer is B, oxygen. Question number 31, The function of FeOH taken rise ferric hydroxide in the contact processes. So option A is what? To remove arsenic impurity, detect a colloidal impurity, to remove moisture, to remove the dust particles. So the main function of ferric hydroxide used in contact process, it has to remove the arsenic impurities. For the removal of arsenic impurities, ferric hydroxide is used in contact process. Therefore, question number 31, answer is A. Question number 32, excess of PCl5 reacts with the constant sulfuric acid giving A. Chlorosulfonic acid, B. Thionyl chloride, C. Sulfuryl chloride, D. Sulfurous acid. Let us see the reaction between sulfuric acid and PCl5. Look here, SO2, this is sulfuric acid, PCl5, first step you are getting, this is SO2, OH, Cl plus POCl3, HCl you are getting first. Chlorosulfonic acid you are getting, chlorosulfonic acid. After this, chlorosulfonic acid, further it reacts with PCl5 again. Then you are getting what? Cl, SO2Cl, same, POCl3 and HCl. This is what you call sulfuryl chloride. Sulfuryl chloride. Therefore, sulfuric acid with excess PCl5 producing the last final product sulfuryl chloride. For question number 32, answer is C. Question number 33. Select the incorrect statement among the following. O3 is used as germicide for purification of air. Yes, O3 is generally used as purification of air and water because O3 decomposes to produce nascent oxygen. Option B, in O3, OO bond length is identical that of molecular oxygen. No. See, molecular oxygen we talk about O2O. The bond order is 2. But to talk about this particular ozone molecule, the bond order coming to be 1.5 only. Bond order is 1.5. Bond order is 2. What is given? In O3, OO, O2O bond length is identical to oxygen is said. No. Bond order is 1.5. Bond order is 2. This is shorter. This is longer. Coming to C. O3 molecule is angular in shape. Yes, angular only. Angular. O3 is an oxidizing agent, well known. It is O3 is actually oxidizing agent. Incorrect statement we want. 33. So option B. What is said? The bond length both are same is saying not. It is shorter, it is longer. Therefore, for question number 33, answer is B. Question number 34. When constant sulfuric acid is heated with P2O5, the acid is converted into A. Sulfur trioxide, B. Sulfur dioxide, C. Sulfur. A mixture of sulfur dioxide and sulfur trioxide. See now reaction between sulfuric acid and P2O5. Look here, P2O5 is actually strong dehydrating agent, dehydrates sulfuric acid. Look here, H2, SO4, P2O5. The reaction between these two, then you are getting what? SO3, 2HPO3 you are getting. 2HPO3. In this way, sulfuric acid dehydrated to sulfur trioxide. So, question number 34, sulfur trioxide is the answer. So, question number 34, answer is A. Question number 35, sulfur does not exist as S2 molecules because option A. Less electronegative, is not able to constitute p-pi bond. It has ability to exhibit catenation of tendency to show variable oxidation states. See, in this particular 60A group, O2 diatomic gas exists as diatomic gas. But sulfur you take, selenium you take, tellurium you take. These are all actually octaatomic solids. Octaatomic solids. Why? Because of smaller atomic size, between oxygen and oxygen atom, p-pi bonding is there. Between the two oxygen atoms, p-pi bonding is there, easily forming, and therefore O2 only exists what a diatomic gas. But whenever you talk about sulfur, selenium and tellurium, they are bigger in atomic size. Between the bigger atoms, there is no formation of p-pi bonding. So between these bigger atoms, p-pi bonding is not possible. Therefore, these are generally existing what octatomic solids. Therefore, question number 35, answer B is given as what? It is not able to constitute p-pi bonds. Therefore, question number 35, answer is B.